All right, it's going to look a little different today because I need the graphing calculator, but we're on 1.7 day 2. We're going to continue modeling with functions. And the first thing we're going to talk about is when you have to compare equations. It says write an equation for each situation, set the equations equal to each other, and you can solve it algebraically with systems. We're going to use the graphing calculator. We're going to type the first equation into the graphing calculator for y1, the second for y2, and then we're going to calculate when they're equal. So as an example, it says Sally is considering 2 job offers. Verizon's equation would be they're offering a base salary of $18,000 plus 20% of all sales. I don't know the sales, so I call it X, and of means multiply. She's also offered a salary from AT&T. AT&T's offering $22,000 plus a commission of 8% of all sales. So if I go to my graphing calculator, and for y1 I'm going to type in 18,000 plus 0.20x. For the second equation, we're going to type in 22,000 plus 0.08x. And if I do a zoom 6 to get a standard window, as long as these lines on the side are running, it means it's trying to graph. Once it's done, it's done. And I don't see anything, which means either I typed something wrong or my window's wrong. Well, if I look at my equations, all right, these things are not even going to touch the y-axis until this one 18,000 and this one till 22,000. So clearly I need to change my window. So I go to window, and I know I need to go much, much higher. So I'm going to go to 30,000. One more 0. And then I'm going to count by, I don't know, 5,000s. So now if I hit graph, we'll see if we can see anything. Well, there's one line, there's the other line. Well, they look like they're parallel lines, which I know can't be true because the slopes aren't equal. So I'm seeing something, so I'm thinking my y-axis is good, but clearly I can't see where they cross, so they look parallel, so I need to look farther on my x. So I'm going to go to, I don't know, maybe 10,000 and count by thousands. And if I hit graph again, oh, see, now I can see that it's not a straight line. That one's not either, but I still can't see them cross, so I need to go farther on my x. So I'm going to go to, I don't know, I might as well go to 30,000. And we'll count by 5,000s too, just like we did on the y. Oh, look. Oh, I still can't see them cross. Almost right there. So let's go a little farther. Let's go to, oh no, I don't want to do that. Let's go to 35,000. Because it looked like I almost had it. Maybe a little farther. Let's go to 45,000. And there we go. I can see the intersection is right there. So we're going to calculate the intersection point. First curve, enter. Second curve, it went to the other line, enter. No guess, enter. And there's my intersection. And it says that x equals $33,333.33. And y equals $24,666.67. Now, let's look at what that means. All right, at this point, she'll make the same salary regardless of whether she works at Verizon or AT&T. Okay, if she sells $33,333.33 worth of merchandise, her salary will be $24,666.67, whether she works at Verizon or AT&T. That's the break-even point. That's when it won't matter where she works. So what's your advice to Sally? Well, if you look at the lines, this first one down here is Verizon. I can tell because it starts at 18,000, so it starts lower. So this is the line. Right here, so at $33,333, okay, before that point, she's going to make less money working at Verizon and more money working at AT&T. But after $33,000, if she sells more than that, she'll be making more money if she works at Verizon instead of AT&T. So my advice to her would be, if she can sell more than $33,333.33, then she should work at Verizon. If she's going to sell less than that, then she should work at AT&T. Okay? Alright, so you can try this one, and you can see that the answer is going to be Ford. Okay, try that one, see if you get the right answer. Okay? Alright, maximizing a quantity. When you're maximizing a quantity, you need to either get an equation or write an equation, type it into the calculator, and then use the maximum function to calculate the maximum. So on this next one, it says a square of side x inches is cut out of each corner of an 8 by 15 piece of cardboard. So let's draw that. We've got a 8 by 15. So this is 8, this is 15. And they're going to cut little squares out of each corner to make a box. And they don't know how much to cut out to maximize the volume. Okay? So what I have to do for A, it says write the volume of the box as a function of x. Well, volume equals length times width times height. But I have to name these in x. Well, we have a different... This isn't 15 anymore, because I'm going to take away x here, and I'm going to take away x here, which means this side is no longer 15, but it's 15 take away 2x, an x at the top and an x at the bottom. Okay, that's going to be my new length. My width was 8, but again, I'm going to take off x on this side, and I'm going to take off x on this side. So the whole width now is going to be 8 minus 2x. And the height is going to be, if you fold it up, it's going to fold up a length of x. So now I can write my equation for volume. Instead of length, I'm going to put 15 minus 2x. Instead of width, I'm going to put 8 minus 2x. And instead of height, I'm going to put x. And for A, we're done. We wrote an equation for volume of the box defined as a function of x. For B, it says find the domain of V as a function of x. Note that the model imposes restrictions on x. Why are there restrictions? There's no drama, there's no denominators, there's no radicals. Why are there restrictions on my domain? Well, you can't take more than 8 away from this side, and you can't take more than 15 away from this side. So we're going to be restricted on how much we can actually cut out and still have a box left. In other words, if x was 4, I would take off 4 from this side, 4 from this side, and I wouldn't have anything left. So x is going to have to stay less than 4. And it can't even be equal to 4, because if you take exactly 4, it's going to be too much. So my domain is the set of all x such that x has to be less than 4. Okay? And it can't be negative, obviously. So it's got to be greater than 0. Okay, so there's B. For C, it says graph V is a function of x over the domain found in part B and use the maximum you found finder on your grapher to determine the maximum volume such a box can hold. So I've got a picture there, but I'm going to go back to my graphing calculator. We're going to go back to y equals. We're going to clear out everything we did before, and I'm going to type in my new function. Oops. So I'm going to have 15 minus 2x, parentheses, 8 minus 2x, parentheses, x. And if I do a zoom 6, that will take me to a standard window. and I can't see. I'm expecting some sort of a cubic function because x times x times x would be some sort of an x cubed, and I can't see that, so let's change our window. Now we already said we had to restrict our x to between 0 and 4. So I'm going to go to my window, and I'll leave it at -10, and I'll go to, just so you can see. Well, no, let's do our domain. So we'll go from 0 to 4 and count by ones. Now I wasn't seeing anything high enough, so just in all interest, let's maybe go to, 100 and see if we can't see anything. So if I go to graph, I can see that section of it. Again, just again, this should be a cubic, but we're looking at just a section of it. So right here between 0 and 4, because anything after that, even if there's another high point outside of this, it's not going to make any sense in the context of the problem because you can't take it more than 4 away from the sides. So looks like right there is my maximum. So I'm going to calculate my maximum, and you need to get on the left side of the hill. About right there is good. And then for the right bound, you need to get way on the other side of the hill. Are you sure you're not on top? Enter. And then enter one more time. And it says that my maximum is 1.67. We'll round it. And for y, you get 90.74. What that means is I will get a maximum volume of 90.74, whatever we're in, inches, okay, cubed, if you cut out 1.67 inches off from each square. That will give you the maximum volume ever. If you take anything less than 1.6, oh, I'm off the grid, sorry. If I go anything less than 1.6, see how my volume's getting less and less and less right here? If I follow the curve, the highest I get is 90.74, and then it starts going back down again after 1.67. Okay? Hopefully that makes sense. So D says, how big should the cutout squares be in order to produce the box of maximum volume? 1.67 inches. Okay? Alright. Sorry. Oops. Alright, you can try this one and see if you get 1.6 by 1.6. Okay? Mixture problems. If you're trying to find the total amount of mixture required, define one quantity being mixed as x, define the second one being mixed as how much ever total you have minus x. Then you're going to write your equation. The percent of the first amount plus the percent of the second amount has to equal the percent of the total. And then we're going to solve it for x. Okay, so it says how much of a 10% solution and how much of a 45% solution should be mixed together to make 100 gallons of 25% solution. I like the barrel thing, okay, which I can't draw very well, so I'm just going to make circles. This is the solution 1. This is the solution 2. And this is the total, okay? And we're going to basically mix these things together. So the first solution plus the second solution has to equal the total. So let's figure out how much of this stuff we have. We're trying to make a total of 100 gallons. So this total over here has to come out to 100 gallons. Well, they don't tell me how much either of these are, so I don't know. We'll call it x. Well, if there's 100 total, and I use x of it here, then how much is left would be 100 minus x. So there's your amounts of the solution, okay? The next thing you have to know is what is the concentration of each solution. Well, solution 1 is a 10% solution. Solution 2 is a 45% solution. And they want the 100 gallons to be a 25% solution. They're taking a weak solution, adding a stronger solution, and want somewhere in the middle. Okay? once you've got that, here you got your equation. You're going to take 0.10 times x plus 0.45 times 100 minus x equals 0.25 times 100. So if I simplify this and start solving it, I have 0.10x plus 45 minus 0.45x equals 25. Okay, we're going to combine like terms, and I have 0.10 minus 0.45 is a negative 0.35x plus 45 equals 25. I'm going to subtract 45 from both sides. I get negative 0.35x equals negative 20. And then to get x alone, I'm going to divide by negative 0.35. So I have negative 20 divided by negative 0.35, and I get x equals 57.14 gallons. So to answer the question, which was how much 10% solution and how much 45% solution, well, there's my x, which goes right here, and to get this one, I have to take 100 minus x. So my answer for the amount of x is 57.14, and to get this one, I'm going to take 100 minus 57.14. 100 minus 57.14 gives me 42.86 gallons. Okay, so to answer the question, we need 57.14 gallons of the 10%, and we need 42.86 gallons of the 45%. That's your mixture problem. Okay, you can do this one and see if you get the 24 liters. All right, for slide 14, looking at this one, the other one's the same way. This one's talking money. It says, Sue invested $10,000, part at a 5.9% annual interest, and the balance at a 6.6% annual interest. How much is invested at each rate if a one-year interest payment is $634.03? Okay, so we're mixing money. She's investing in two different places to get a total of $634.03 was her interest payment. Okay, so if we want to figure out how much is invested, she's got $10,000 total. Sorry, that should be my total. I don't know how much she's going to invest at 5.9%, which would be 0.059%. I don't know. So that would leave 10,000 minus x to invest at 6.6, which would be 0.066%. Okay, and it says how much is invested at each rate if a one-year interest payment is $634.03. Okay, so we had a total of 10,000, okay? We're going to invest X of it at this percent. We're going to invest the rest of it at this percent, and that's got to come out to, not 10,000, but that's got to come out to my interest payment of $634.03. So if I write my equation, I have 0.059x plus 0.066 times 10,000 minus x equals 634.03. Distribute, and I have 0.059x plus 660 minus 0.066x equals 634.03. If I combine my like terms, my x's, 0.059 minus 0.066, I get negative 0.007x plus 660 equals 634.03. I'm going to subtract 660. I get negative 0.007x equals 634.03 minus 660 gives me a negative 25.97. I'm going to divide by negative 0.007, and I get x equals, negative 25.97 divided by negative 0.007, which gives me x equals $3,710. So I'm going to invest $3,710 at this interest rate, and to get how much to invest here, you take 10,000 minus your x. So if I take 10,000 minus 3710, I get 6,290, which is why that's my answer. Oops, that's my answer. Sorry, I'm making a mess. Not that. That. Okay. All right. And percent increase or decrease problems, you just use your proportion. The difference in amounts over the original amount equals your percent change over 100. And then cross multiply and divide. So it says from December 2006 to December 2007, the number of cell phone antennas in the United States grew from 195,613 to 213,299. What was the percent increase in the U.S. cell phone antennas in that 1 year period? Well, again, our proportion is difference over original equals P over 100. So first thing I have to do is find the difference. So I have 213,299 minus 195,613. The difference is, 213, I need to be careful, 299 minus 195,613. 213, okay, is, so the difference is 17686 over the original, which was, in this case, the lower number because it increased. So my original was 195,613 equals percent over 100. So if I cross multiply, this gives me 17686 with 2 more zeros equals 195,613p. Divide that, 195,613, 195,613, and my percent increase is divided by 195,613, and I get the percent of change is 9.04, so approximately 9%. Okay, it's percent increase. All right, so if you try this one and see if you get the 18.4. And what else we got? Unit conversion. All right, for unit conversion, we're going to be talking about rotations of tires. So a tire is obviously round. A circumference would be the distance around the circle. So would you agree that one rotation would equal one circumference? Okay, that's what this is. And then remember, to find circumference of a circle, it's pi times diameter. All right, so then we're going to set up a series of conversions to get to the end. All right, so here's what we're talking about. It says, how many rotations does a 15-inch radius tire make per second on a sport utility vehicle traveling at 70 miles per hour? So we're starting with 70 miles per 1 hour. Okay, we have to somehow get this down to rotations per second. So I'm trying to get miles to rotations and hours to seconds. So the first thing I'm going to do is focus on time. We're going to have to convert both, so I'm just going to get rid of my time first. If I want to get rid of hours, I put it on top. I ultimately want to go to seconds, but I'm going to have to go from hours to minutes first. And there are 60 minutes in 1 hour. The hours would cancel. Okay? That's going to put me in miles per minute. I don't want minutes. I want seconds. So if I want to get rid of minutes, I'm going to put that on top, and I want to go to seconds, that's going to be on bottom. And there's 60 seconds in 1 minute. That will cancel minutes. So if I simplify what I have, that's going to give me 70 miles over 1 times 60 times 60, which 60 times 60 is, that's going to give me over 3,600 seconds. So now I've got the time right. I'm at 70 miles per 3,600 seconds. So I've got my seconds down. Now I need to go from miles to rotations. Okay, well, first of all, I got to get rid of miles. So to get rid of miles, I don't want miles. I'm going to put miles on the bottom. I don't know how to get to rotations yet, but I know I can get to feet. There's 5,280 feet in 1 mile. That will cancel miles and put me in feet. But I don't want to be in feet. I need to be in rotations. So my tire is in inches, the diameter. Did they give me the diameter? Radius, sorry. My tire has a 15-inch radius. So I need to get to inches. Well, I can do that. If I don't want feet, I'm going to put feet on the bottom and inches on top. And there's 12 inches in 1 foot. So feet cancel feet, and now I'm in inches per second. I don't want inches. So I'm going to have to get rid of inches. So I put inches on the bottom. And now I can go to rotations because that's what my tire is in. Now that's going to take a little figuring, but it's not hard. Okay? If I can get the circumference of the circle, I will know what 1 rotation is, and I can put it up here. So if my radius is 15, then my diameter is 30. So my circumference equals 30 pi, which I can type in 30 times pi is, my circumference is approximately 94.25 inches. That is what 1 rotation is. So in 1 rotation, there are 94.25 inches. Now inches will cancel, and I am finally in rotations per second. So now I just have to do the math. On top, I have 70 times 5280 times 12 times 1, but I don't have to put that. On bottom, I have 3,600 times 94.25. So if I type that in, 70 times 5280 times 12 divided by 3,600 times 94.25, enter, and I get approximately 13.1, and we are in rotations per second. And that's what it asked for. Okay, how many rotations per second does this tire make traveling at 70 miles an hour? Okay. All right, so you try this one and see if you get the right answer. And I'll work this one out with you just in case you didn't. Okay, so we have a tire that has 18 inches radius right? Which means its diameter would be 36 inches. Okay, we are, let's see, it says a tire of a moving bicycle has a radius of 18 inches. If the tire is making, oh, they're going backwards, so you're going 3 rotations per 1 second. They want to know the bicycle speed in miles per hour, so I'm literally going to go backwards. So again, I'm going to take care of my time first. So if I want to get rid of seconds, I'm going to put seconds on top, and I can't go straight to hours, but I can go to minutes. There are 60 seconds in 1 minute. That gets rid of seconds, but I don't want to be in minutes, I want to be in hours. So to get rid of minutes, I put it on top, and I put hours on bottom. There's 60 minutes in 1 hour. Minutes are gone, and now I'm in rotations per hour, so I have my time right. So let's simplify that. On top we have 3 times 60 times 60, which is 3 times 60 times 60 is 10,800 rotations per 1 times 1 times 1 is per 1 hour. So I'm in the right time now. So let's recopy this, 10,800 rotations per 1 hour. Okay, now I've got to work on getting rid of the rotations. So I need to come back up here. I want to get rid of rotations, and eventually I want to go to miles. Well, the first thing I'm going to be able to go to is inches. So if I calculate my circumference, which is 36 pi, I get about 113.1. We'll say my circumference is going to be 113.1 inches, which circumference is 1 rotation. So 1 rotation is worth 113.1 inches. And now rotation is gone. But I don't want inches per hour. I need to get to miles per hour. So I want inches to go away. I'm going to put that on bottom. I can't go to miles yet, but I can go to feet. There is 12 inches in 1 foot. And now inches cancel, and I'm in feet per hour. One more, and I can get to miles. If I want to get rid of feet and go to miles, there's 5,280 feet in 1 mile. Feet cancel, and now I'm in miles per hour. So on top I have 10,800 times 113.1 times 1 times 1. On bottom I have 1 times 1 times 12 times 5280. So if I type that in, 10,800 times 113.1 divided by 12 times 5280, close your parentheses, I get 19.28, and I am in miles per hour, or mph you could have put. Okay, and there we go. All right, so how can you identify which of the 12 basic functions most appropriately model the real-world situation? I don't know that we're basically using the 12 basic functions. We're using area models, circumference models, volume models, conversion models to solve equations or to solve problems. All right, so the rest is your homework. Have a good day, and I will see you next time.